Welcome everybody. This is Ms. Parsons coming at you. Today we're talking about simplifying radical expressions. So please get your notebook out and be ready to take some notes. So what is a radical expression? It's an expression containing a radical symbol. The one you most commonly see is a square root, but it's not always a square root. You can denote a cubed root, a fourth root, or even higher. So what does it look like? Well, it can be complex with algebraic terms in it like x and y. It can be negative, or it can be fairly simple like the square root of 24. There are different parts to a radical. The number out in front is called the coefficient, just like if you're working with an algebraic term, the number out in front is the coefficient. The number by the radical is called the index. If you do not see a number there, that's typically a hidden 2, which we call a square root, but sometimes they can be even larger numbers like 6. And inside the radical is called the radicand. So how do we simplify a radical? Well, the first thing you're going to do is you're going to create a factor tree. So you write 48 up at the top, and you're going to find two numbers that multiply to 48. So the first thing that pops in my head is 2 and 24. Okay, maybe you picked 4 and 12. That's fine. So 24 can break again into 6 and 4. 2 doesn't break because it is a prime number. The only thing that breaks into is 1 and 2. And if you go off on that tangent, you'll be writing 1 and 2 forever. So this is a prime number, so it just stays 2. 6 breaks again into 2 and 3. Those are both prime numbers, so they don't break anymore. And 4 breaks into 2 and 2. Well, why this 2 doesn't want to stay here, I don't know. All right, so then we are going to circle pairs of numbers. Now, pairs are 2, so I have a pair of 2's here, and I also have a pair of 2's here. Okay, why pairs? Because this is a square root, which is a hidden 2. Apparently, I can't write 2's today. Okay, there's a hidden 2 there, which means I'm pulling out pairs. So if there was a 3 as the index, we'd be pulling out groups of 3's. So I'm going to pull out my pairs. All my pairs are going to go outside the radical. So I had a 2, and I also had another 2. And then anything that did not break is going to stay inside the radical. So the only thing that didn't break was this 3 here. So he's staying inside. We're going to multiply the numbers outside the radical, creating one coefficient, and then multiply the numbers inside the radical, creating one term in the radicand. So on the outside, I had 2 and 2. Well, 2 times 2 is 4. And the only thing that was in my radical was that 3. So if I simplify the square root of 48, that becomes 4 square roots of 3. So say I have the square root of 60. We're going to do the same thing. We are going to create a factor tree. So 6 and 10, 2 and 3, 5 and 2. Now these are all prime numbers, so they do not break anymore. Okay, my index is 2, so I'm looking for pairs. And all I have here is a pair of 2's. So the pair comes out. I had a pair of 2's. And then your radical, think of it as your leftover container, putting in the things that did not break. 3 and 5. So your step 3 is to multiply the numbers outside the radical. Well, I only had a 2. And then multiplying the numbers inside the radical, 3 times 5, which is 15. I apologize if that keeps coming up. 15. Come on, PowerPoint. You can do it. All right. So square root of 60 simplifies to 2 square root of 15. Okay, kicking it up a notch. Sometimes we have algebraic monomials inside the radical. So that means we're going to start throwing some variables at you. So I know that if the exponent of my variable is greater than my index, then the monomial can be simplified. And we're going to take the sets of n, so like we were looking for pairs, okay, but they might be sets of 3, sets of 4. We're going to take that number of sets out of the radical. Okay, so in my first box here, I have an index of 2. Okay, so that means I'm going to pull out pairs. So if it helps you to visualize it, we can write all these out. X to the third is x, 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 3 x's. Y to the fourth is 4 y's. 1, 2, 3, 4. So I'm looking for pairs. So I've got 1 pair of x's with 1 left over. And then I've got 2 pairs of y's. So all my pairs are coming out. I had 1 pair of x's. So that's just x to the first. And I had 2 pairs of y's. So that's y to the second. And then in my radical, that's my leftover container, I'm putting everything else that didn't get to come out, which was just this x. Okay, what if I did the same thing with this guy? But now I'm not looking for pairs. I'm looking for groups of 3. So maybe I want to write this out. X, 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 Y, 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 Y. And I'm pulling out groups of 3. So I've got a group of 3 here and a group of 3 y's here. So I had 1 group of 3 x's, 1 group of 3 y's, okay? And then inside my radical, making sure that I put the correct index there, I put my leftovers here. Okay, you can also think of it as a division problem. 3 divided by 3 is 1, so I had 1 set, no left over. 4 divided by 3 goes in 1 time, so I had 1 set come out with a remainder of 1. So the remainder is what goes inside the radical. So let's try and do it with this guy. I now have a 4th root, so I'm looking for sets of 4. I have 3 and I have 4 y's. Okay, remembering the last screen, if I know this number is bigger than this number, it can be simplified. But 3 is not bigger than 4, so I should know already that that's not going to be simplified. But when I write it out, I can see I can't pull out 4 x's because I only have 3. Okay, so, but I do have 4 y's. So I can pull out a set of 4 y's with a 4th root. And in my leftover container, I have 3 x's left over. So x to the third. Okay, so now let's put some coefficients out. Let's put it all together here. So in this first example, I have an index of 2. Of course you don't want me to write the 2 there. All right, so I'm looking for sets of 2 for 6 x's. Well, 6 divided by 2 is 3 with none left over. So outside of this radical, with my x to the 4th, I'm also going to have 3 x's, 3 sets of 2 x's that I pulled out with nothing left over, because if I had the 6 written out, I would have already taken the 3 groups out. So there was nothing left over there. So what do I do with these guys? Well, I'm going to multiply them together, and exponent rules tell me that I add these exponents together. So that gives me x to the 7th. Boy, oh boy. All right. So now I have this guy, got a coefficient of 6, got an index of 2, okay, and I have a number in here, and I have some variables. So the first thing I want to do, I'm going to come over here to the side, and I'm going to make my factor tree, okay? So let's see, 9 times 8, the first thing I think of, and then 9 breaks to 3 and 3, 8 breaks to 4 and 2, and then 4 breaks again to 2 and 2. Okay, so on the outside I have my 6, and I'm going to pull out a pair of 2's, so that comes out. I also have a pair of 3's, so that comes out of the radical. Okay, so I've taken care of my 72, but I had a 2 left over, so he's going back in the radical. He couldn't come out because he didn't have a pair. And then I have an x squared. Well, keep in mind that that's x, and I'm pulling out a pair, so I can pull out both of these. I had 1 pair of x's here, right? So my next step is to multiply everything on the outside. So this becomes 6 times 2 times 3 is 36x square root of 2. So those are my simplified answers.